What a terrific start for VBS. Man, what a great crowd we have. We're going to have a full house. We already have it for Bible class, for worship. It'll definitely be that way. We're really looking forward, as I mentioned, to our study of Operation Creation. Our whole 2023 theme is going to be based off of that. And we're really going to be focusing on the creation of our God and go back to the specifics of how everything took place. We're going to be contrasting that some with what we hear as far as the way things happen and compare that to science as well as Scripture and see in the end how it is that these things weigh out. There are going to be two ideas that will be consistently placed before us. And these two concepts are going to be whether all of this is a production of nature or whether this is a supernatural creation that we find around us. A natural or super meaning outside of creation. And really it's just a simple conversation of evolution versus intelligent design. And we're going to try to decipher which one of these makes more sense. And obviously we know what the Bible teaches about it, so it'll be a little different this week. We're not going to spend as much time in Scripture because that's what we do on a regular basis. If you don't care as we get started, what I'd like for us to do is turn to Psalm 19. As I mentioned, we won't have a lot of time in the Bible, but I want to show you from the Bible why that's going to be the case. So Psalm 19, and we're going to read there the first about 4 verses. We won't go through all of the number 4. But Psalm 19, starting in verse 1. The heavens declare the glory of God, and the sky above proclaims His handiwork. And essentially what's being stated there is even though this is written into inspired Scripture, you don't have to have inspired Scripture to know that God exists. And you don't have to have inspired Scripture to know certain things about Him. Now, it's true that the Bible backs up all of those other things that we find. And it's true that the Bible gives us more information. You know, nature can tell us that God exists. Nature can tell us things about God. But nature itself can't tell us how to find God one day. And that's the real significance of the Bible. But the heavens declare, you don't have to have the Bible to do that. The creation itself declares the glory of God. And the firmament shows His handiwork. Look on down into verse 2. Day to day pours out speech. You can look out and see things by the illumination from the sun. In fact, we're going to talk about, and I think the reference here is even to the sun itself, and it'll tell you all kinds of things about God and His existence. Night unto night reveals knowledge. It's 24 hours a day. Just look out in creation and you can be blown away by the wisdom and the power of a supernatural being that must exist. Verse 3, there is no speech, nor are there words, whose voice is not heard. Perhaps meaning you don't have to have someone to tell you this. Just use your eyeballs. And you could observe this for yourself. You don't have to have a doctorate degree in science to figure this out. An everyday, common person who has no educational background can understand these simple facts about God, even from nature. Verse 4, their measuring line goes out through all the earth, and their words to the end of the world. And what we're told in Psalm 19 is it's really an inspired song all about the revelation of God, how God shows Himself. And it's neat, if you look at the second half of Psalm 19, it's all about the Bible and how inspired Scripture tells us things we need to know about God. But the first half of it, a chunk of which we've read right there, is just about nature itself. And so you have supernatural revelation in the Bible, what we call it today, that tells us so much about God. But the first half of that psalm is about how you have just nature itself that tells you all sorts of things about God. And so we're going to be looking not so much at the Bible like we commonly do. There will be a little bit of that tied in. But so much of it is just going to be an appeal to, we're going to be looking at nature to try to figure out what makes the more sense about why it is that we have all these things that we do. Is it naturalistic evolution, or is there an existence outside of ours that must be an intelligent designer that generated all of these things? We're going to be talking about evolution, as I've mentioned a lot this week, and there are two very different types of evolution. The first of these is microevolution, and the other one is macroevolution. These are two completely separated concepts. And I bring this up because these often get confused with one another because the main base is the same, evolution. And so it's like, well, all evolution's the same. And you can't just lump it all into a single category, though. You need to look at it from two perspectives. First of all, who can help us out in our class period here? What is, hold on just a second, who's ringing our bells? Hey, AJ, you ringing our bells? Huh? Garbled. Huh? Oh, Chad is. Okay, hey, Chad. Sorry, I forgot to get with you. Don't forget at 50 to ring the first bell, 55 the dismissal. It's a little bit different this morning. Yeah. Yes, sir. And then 55 is the second one, dismissal. Sorry about that. Thank you. Okay, so can anyone help us out in our class period? What is microevolution? First of all, evolution means... Yes, sir. You. Go right ahead, Scott.
Micro would be evolving to live in a desert better or
Okay, good.
a winter better.
Good. That makes a lot of sense. So let's look at evolution first. Evolution means what? Generally, it's just change. Okay. Do things change? Yeah. Do things evolve in the sense of do things change some over time? Absolutely. Everything changes over time. There is a such thing as evolution in a general sense, right? Okay. So, Scott, when I hear micro, I think micro machine. Anybody play with micro machines growing up? That means you don't have the real deal, and mom and dad buy you your first car, and back then it probably cost 48 cents. That's a micro machine, okay? It's not the $48,000, it's the 48-cent one. There's a difference. What does micro mean? Why is it so cheap? It's small. It's a very small scale of the big reality. And so evolution, change, and micro, small. And so yeah, it's just small changes or small adaptations that take place over time. Sometimes it's cycles that'll go, and then a cycle will get reversed. Yeah, go ahead.
You know that Shannon's dad, my father-in-law, was a science teacher. He explained microevolution in this way, especially when Caden was born with his red hair. The genetic trait for red hair in the human population will one day not exist.
Huh.
That is not a genetic entity that's easily passed on. And so there will come a day, yes, the human race lasts that long, Jesus didn't return. There will no longer be any red-haired people on the planet.
Yeah.
Very small changes.
Yes. So it gets smaller, that changes over time. The gene pool, our genetics get closer and closer the longer the human race goes on, which it becomes even more important to marry further away in your family lineage, okay, because genetics can get messed up. Very good. Yeah, they're very small things. You compare, have you noticed the sizes of kids' feet today? Don't they seem a little bit bigger than when we, some of you maybe not, but for a number of us, when we were younger? Okay, are we talking they're the size of Texas now? No, that they're, a lot of times maybe on average about a size bigger than they. I mean, that's a very small change, these types of things. And for instance, today we have all kinds of species of dogs that we didn't one day have. How do we accomplish that? Well, we just took a couple different breeds of dogs that had never been bred before. We crossbred them. But we started with canines and we ended up with what? Canines, okay? Kids' feet are maybe a little bit bigger than what they were decades ago. Okay, but we started with human feet and we ended up with what? Human feet. You see, I mean, they're not massive changes. We're not talking about, dogs have become human beings through the years or human beings have digressed back into, it's not anything like that. That's micro or very small changes over. No one's debating that there are small changes that do occur within families of living creatures over time. Here's where the big debate happens, though. It was Charles Darwin who presented the concept, or at least became most famous for it, of macroevolution. And as opposed to micro, what does macro mean? Large scale. It's big. And so huge changes. What kind of changes are we talking about here? Okay, so one family of creature goes into a totally another. For instance, the one-celled amoebas turn into fish, and fish crawl out of the water, and they turn into all land dwellers. Dinosaurs turned into birds over time, and apes turned into human beings. We're talking about crossing families, massive scale evolution. And I just want to point that out because sometimes there's some misunderstanding in this conversation that occurs. And when someone says, well, I'm not real sure about evolution. Oh, you don't believe changes happen? Well, yeah, of course. We believe small changes do happen within families of creature. But the debate is, does one type of creature totally morph into another over time? And so I want to say that not only for my sake, but as well for all of our teachers. You're probably not going to hear us every time we refer to this concept, macroevolution. That's too big and it takes too long. But when we refer to evolution, we're talking about that of a macro level. One type of creature totally going into another. Roy?
One primary difference is that micro is scientific fact.
Sure.
Macro is myth.
You're right. It's not fact. It's not theory. It's not even hypothesis. And it's just middle school science. It's just basic common sense. Good, Roy. So we're going to be exploring all these things, but we're going to start in this class with the first proposed type of macroevolution that ever occurred. And it has to do with the origins of the universe, cosmic evolution, and that is the evolution of all that we know, all the galaxies that are in the place where we live. Have you ever noticed that in nature there is remarkable design that's found? Marty, the last few years, I think, teaching some math in school has helped me to appreciate and observe more just all the geometry, all the mathematics, all the calculations, all the numbers that are found in nature. It's simply remarkable. Now, I'm not going to get into, where's Chet? I'm not going to get into the plants and the animals. Okay, I just wanted to say, that's going to be him on another night. But it is remarkable. We are going to focus, though, just a little more on the physical side of the creation itself, more of the non-living sector of things. Let's talk a little bit about the Earth and try to figure out, is there any design that's found on planet Earth? Well, it really gets hot on days like these, doesn't it? And you got to be careful about those ultraviolet rays. What do we have above us, though, that helps us as far as the rays of the sun? Yeah, absolutely. And in chemical composition, it's O3. You have 3 oxygen atoms that are bonded together, and that forms our ozone layer. That ozone layer is found about 12 to 18 miles above the Earth, and it filters out much of what would be harmful to our skin and our eyes, that radiation that comes down from the sun. What a wonderful accident that we have that nice little shield that helps protect us from the sun. There's actually another shield, though, that helps us relating to the sun, and this is Earth's magnetic field. It reflects potentially dangerous solar winds back into space that are comprised of protons and electrons, and without the magnetic field, sun-wise, we would also be in a pretty rough spot. I felt for a long time this is one of the most powerful designs that is so simple that's found on planet Earth. I think we probably find out about it first, second grade, maybe even kindergarten, and that's how we get water. How does water come to us? By the way, water's pretty important. We're comprised of roughly how much water, you and I? 70-ish percent. The globe, the planet, and all living specimens here depend on water for survival. We just so happen to be in a place, and the land surface is made up of what percentage of water on planet Earth? Okay, very good, 70-ish to be exact. 72 is what it is. We often say 3/4, and that's about right, okay? About 3/4 water. So everything needs water. How do we get this water as we need it? Just pick up your cell phone and I need water. Huh? Oh, okay, all right. So you have to wait a little bit. You have to be patient. The water cycle. Evaporation, okay, through heat, the transfer. We'll talk more about that in a little bit. Through heat, the transfer of an element from one state to another. So it goes from a liquid to a gaseous state. And it also has to do with temperature fluctuation, the condensing of water particles around pieces that then become heavy enough, precipitation occurs. And this cycle just keeps going. Do you realize there is no new water on the planet? Never has been, never will be, since it was there and since it was made. It just gets recycled over time. So the same water you and I are using is the same water that the ancient civilizations, Egypt, Adam and Eve, it's the same water. And it just gets recycled. We all have to have it to survive, and it's strange. There's so much of it that's found here. And if it were up to God, we wouldn't have to pay anything for it. It's just all natural. But of course, we found a way to make money on that also. Pretty neat how the water cycle works. I want to talk just a little bit more about it, though. Water acts as a tremendous insulator. Have you noticed that in the tropics, the temperature stays very consistent? Some of that has to do with latitude, but a lot of that has to do with humidity also. The more water there is, the more constant the temperature is. Now, in the hottest places, some of the hottest places on Earth, in deserts, I mean, it'll get scorching hot during the day, and the same day, what happens at night? You're staying out there, you might get a little chilly. Why is that? Deserts, by definition, have very little, not no, but very little water. They don't have the same amount of insulation. And thankfully, there's all this water that's found on the planet because it helps to keep the temperature at a very constant rate. It serves as a natural air conditioner and as well a natural heater for large land masses. There's something else that could be stated, though, about water and what it does to the Earth's atmosphere. You realize that from pole to pole, season to season, the average temperature across the entire globe is 56 degrees. 56 degrees Fahrenheit. The entire globe, season to season, pole to pole. It is the absolute most perfectly inhabitable planet known in the universe. A lot of that has to do with water and the insulation that it provides. Speaking of life and the need of water, what's the one thing that's more of a requirement to us than water? It is for me anyway. Huh? Oxygen. Okay, we have to have air, right? And there's not really any new air that's being made. So we have all these living creatures that need air. There are about 8 billion of us, a little bit over, right now on the planet, and as well, of course, other mammals and so on. We need air. There's no new air being made, so where do we get our air? As we breathe, we take in what we need, oxygen, and as we breathe out, we put off what would be poisonous to us if it were to stay in our system. That's carbon dioxide. And it just so happens that the abundant greenery on the planet requires and breathes in the opposite of what we do, carbon dioxide. And then it kicks out what would be more toxic to it, oxygen. And we say, thank you very much. Trees say, thank you. All right? Isn't that amazing how that works? It's almost like it was just designed for it to be that way. As the Earth rotates around the sun, or as it goes around the sun in an elliptical pattern, it's kind of like a tilt-a-whirl, and this makes me sick just thinking about it. It moves two ways. So it's going around the sun, but also it's spinning as it does. I don't do tilt-a-whirls. The last time I did that, I was sick for like 3 days, and that's no joke either. I don't do tilt-a-whirls anymore. But I live on a tilt-a-whirl that I can't sense its movement, thankfully. It has a rotation on its axis all of its own. If that rotation of planet Earth were halved or doubled, then the seasons of planet Earth would be adjusted accordingly, and it would make it difficult to impossible to grow the required food to support the population of Earth. But it rotates just exactly the way it needs to in order for the growing seasons to be the length they ought to be. The Earth is also, for someone who's a fellow OCDer, this might bother you. You're going through your house and you're looking at that picture, and sometimes I'm not real good about eyeballing things, and so I have a level I'll keep on different levels of the house. I'll just grab that level and put it on top. There we go, straight up. Does it bother you that the poles are not straight up and down on the planet? If we could wouldn't that be a whole lot better, we might think? The Earth has a 23.5 degree tilt to it. Why don't we just straighten that? Do you know that if the planet didn't have that little bit of tilt, if it were perfectly up and down, there would be no seasons on the planet, and that would make for hotter tropics and larger deserts, and we wouldn't have as much space to live as the population of Earth needs. If we were to say, well, let's at least, Marty, make it a little more mathematical, and let's just finish it off, and let's just tilt it at 90 degrees. All right, let's use our square, and let's get it over to 90 degrees. Wouldn't that be better? Well, if we did that, then we would have alternating extremely cold winters and terribly hot summers. Nothing like what we have, way beyond that right now. And again, life on Earth wouldn't work nearly as well. But it's tilted at the absolute perfect angle. Strange, 23.5 degrees, almost like it was planned to be that way. Well, that's just Earth. There are a lot of other things we could discuss, but we need to move on. Let's talk about the moon relative to this planet. I've always been fascinated by it. I love looking at it in a telescope. I even got a Jeopardy question right one time. There's one thing I know about the moon, the Sea of Tranquility. And there was something to ask about the moon, and Vanessa and I were battling against each other. I said, the Sea of Tranquility. And she looked at me like, I was like, that's the only thing I know about the moon. Okay, I got lucky on that one. Moon's pretty cool. Well, what's the importance of the moon? It's more than just, we can look at it at night. Obviously, it reflects some light of the sun, but there's more to it. What's so significant about the moon relative to us? The tides of the ocean. Yeah, absolutely. It keeps those oceans moving. And if they weren't moving, what would happen in those big bodies of water? They would have become stagnant. What happens with stagnated water? It doesn't have the oxygen in it that it needs for plants and animals to survive. All right? And we talked about how important plants are to us and to our survival. And if the plants and the animals in the ocean, if all of them die, that means the destruction of the food chain. What happens if the food chain gets destroyed? Those at the top of the food chain that you and I are going to suffer. We're not going to be able to live if we don't have a moon. But it's not just the fact that a moon exists, it's about the position in which it's found. If that moon were farther away than what it is, by the way, the moon really isn't that far from us. It's only, and it depends on the time of year and from where you measure. Roughly, it's 240,000 miles away from the Earth. Compare that to the sun, Earth to the sun, 93 million miles, so it's not that far away. Jeremy, I'm going to say that you could buy a new Toyota. If you had a highway, you could buy a new Toyota and you could safely drive it to the moon and that Toyota would still be going. Now, if it's, we have Mike, we don't have Mike this morning, but if it were a Toyota Tacoma, you could probably drive it back on that same highway from the moon and still be in the same vehicle. It's not really that far away. But if the moon were a little bit farther away than what it is, it would be so much that it wouldn't control the tides, the oceans would stagnate, all the life in it would die, and as a result, we would die also. However, if the moon were only 1/5 closer than what it is right now, you want to talk about tides, 2 times a day, there would be 35 to 50 foot tidal waves that would come across almost the entire surface of the planet, and it would wipe out life. Nobody would be able to live here. But it turns out that the moon is placed in the absolute perfect position to keep the food chain intact. It's almost like it was just designed for it to be that way. One of the most impressive celestial bodies to me is the sun. Does anyone else feel like the sun gets neglected? We talk so much about the earth and we're fascinated by the planets and about our moon. What about the sun? Maybe it's because it's so bright. Look, I don't know what it is, but the sun is magnificent. We found out so much more about it in recent years, sunspots, solar winds and flares and the like. But the sun's a pretty neat contraption for sure. But it's also vital to the existence of life. Why is that? Not just pretty to behold. It's not just, it makes it a little brighter in the day so we can do more projects. What's the significance of sunlight? There we go. We're talking about the food chain. Of course, to us, it's nice, vitamin D, all right? But photosynthesis, and why is that so important to the food chain? Photosynthesis is the ability of greenery to take the energy of sunlight and to transfer it into food. Now, that's not the only food or fuel that it gets. It has nutrients and, of course, water from the soil. But essentially, it becomes its food. It absorbs it in, and that's so important because these pieces of greenery, they take in carbon dioxide, and then what do they put off again? Oxygen. And then we breathe in that oxygen, and the cycle all continues. You don't have sunlight, guess what else you don't have? Greenery. Not going to work. You don't have greenery, and you don't have oxygen. You're just waiting to use up the oxygen that you have, and once it's gone, it's gone. And human life ceases to exist on Earth. Almost like all of this was just these incredible pieces of puzzles, right, that were put together. There's one other thing that I want to discuss relative to the sun. And I mentioned before the other side of the tilt-a-whirl, and that is the revolution of the Earth around the sun. Of course, we're the third planet, and Mercury, Venus, Earth, and we go around the sun. As we do so, it's not in a perfect circle pattern, though. What's the shape that we use in going around the sun on this planet and all planets? Kind of like it's an ellipse. For a more juvenile mind like mine, it's an egg. It's a football. It's basically, it's an ellipse. And so we don't go in a perfect, equidistant line around the sun. But as we do, every 18 miles, that this planet travels, we pull away from that straight line 1/9 of an inch. And I like to describe that this way. Take your fingers and do this. That's pretty close to 1/9 of an inch. That is such a little measurement that if you were to travel, let's say from this building later this afternoon to the north side of Lebanon, that's about 18 miles. And if it were just one perfectly straight road, for that 18 miles, if you deviated from a straight line this much, you haven't even left your lane in which you start. That's how little, it's minuscule. What would that matter? If the earth pulled away another 1/10 of an inch for every 18 miles that it travels around the sun, it would become so cold on this planet that once again, we wouldn't be able to live on it. If we went just 1/10 of an inch for every 18 miles we travel closer to the sun, any guesses as to what would occur? It would be so hot that we would boil. Well, we might not boil, but we wouldn't be able to survive. The temperatures would be so warm. It has to be exactly 1/9 of an inch every 18 miles. It's almost like it was designed for it to be that way. So we see all this design found on the earth and the moon and the sun. We haven't even talked about the other planets and other solar systems. It's infinite, all the design that's found here. So the question is this: what's the explanation for everything that's in place? There really are only two possibilities. It's either naturalistic evolution or it's supernatural intervention. It's one or the other. The best idea on the side of naturalistic evolution that has been decided is that at one point in time there was a big bang. And, there are a lot of elements to it, but I'm going to condense it. And the short of it is this: that in the Big Bang, there were gases that interacted with one another, and that's what caused this explosion. Those gases then combined with matter. They swirled into galaxies comprised of suns, planets, and moons. Okay, and that's the short of it. There's an explosion, and everything swirls into being. Now, there are three scientific results of this line of thinking. Number one, that an explosion caused something more impressive, more orderly than what previously existed. So an explosion caused something more impressive, more orderly than what existed prior. Number two, energy arose within nature. There's no explanation for that, but all of a sudden there's this energy and maybe some force that propels it. We don't know what it is. But keep that in mind. Energy arose of itself within nature. Number three, matter and energy became more functional and more usable as time progressed. Matter and energy became more functional and more usable as time progressed. We're going to explore each one of these in a moment, but first, if you'll let me, I'd like to read you an excerpt from the book More Big Questions. And this was written by Paul Davies and Adam Phillips. More Big Questions, found on pages 47 and 48. They say this: some scientists speak, just throw energy at it, and it will happen spontaneously. That's a little bit like saying, put a stick of dynamite under a pile of bricks, and bang, you've got a house. They say, of course you won't have a house. You'll just have a mess. Explosions don't build houses. Explosions can destroy houses, but they cannot build houses. There's too much design, too much intelligence that's found in a little tiny house, relatively speaking. And then you consider that the universe is a giant house in which all kinds of living specimens, especially on planet Earth, live. And we can have an explosion and bang, you have a perfectly designed monstrous house. Do explosions build things? Have you ever known of an explosion to build something or make something more impressive in a single instance? Explosions are used not to build things, but to tear things down. So that doesn't seem to add up. Why is it that we have all this intricate design and this marvelous house where we live on planet Earth? All right, I want to read you a second piece from a book. I've had this one for years. This is entitled, In 6 Days, Why 50 Scientists Choose to Believe in Creation. It's a fantastic work. In 6 days, why 50 scientists choose to believe in creation. This information is going to come from pages 301 and 302 of this book. And I put a visual up to help as I read this. On the table in front of me, the writer says, is a reproduction of a beautiful landscape painting of a country scene. dating from about 1770 by Paul Sandby. In the foreground, the artist has captured the sunlight falling on a tree in a meadow. Nearby, there's a horse, some children, and in the background, we see a river making its way past green hill and dale toward the sea. Far in the distance, gray clouds give way to a light blue sky. You ask me how the painting came to be. If I were to insist to you that suddenly, and for no apparent reason, oil paints began to arrive upon a canvas in such a way and in just such proportions that the result was a work of art, you would think me to be mad. It is an impossible scenario. Paintings can't make themselves. Kind of like we were talking last week, books can't make themselves. You have to have an author to make that book and an illustrator. Well, it's the same thing with a paint. A painting can't make itself. You have to have a brilliant mind to be able to design what it is that you see. He says, my difficulties in convincing you would be made worse if I were unable to give an explanation for the existence of the canvas and the paints in the first place. It goes on to say, evolutionary naturalism is asking us to believe in just such a scenario. A picture without a painter, art without an artist. Let us remember also that however good it is, the painting is only a dead, two-dimensional representation of a far more wonderful, three-dimensional living reality. The landscape itself, trees, horses, children, sky, sun, and clouds. Not only does design imply a designer, a design says something about its designer. And I know we kind of hit on this principle last week, but it's just like a science fair exhibit of the solar system. Remember that? An explosion can't make that. It can't put together just a very small scale of the much more infinite reality that's before us. And so if it can't make a tiny little scale, there's no way an explosion can make the big reality. If there's no way that a painting could make itself, or nature could produce a painting of the incredible design of just a picture of a person and animals and landscape, how could explosion or how could nature make the three-dimensional living reality itself, which is so much more impressive? Joe?
Are you going to mention the second law?
I am, yes, thank you. Okay, all right. I'd like to say great minds, but it would be better to say great mind. Okay, so yeah, I am. Thank you. So we have one option. A big explosion made it all. Nature produced nature. Or it could be an intelligent mind designed all of this design which we see before us. Let's explore that concept just a little bit. And as we do so, let's look at the laws of science, three very established ones. So the first of these is the law of cause and effect. And it's very simple. For every material effect, there must be an adequate cause that precedes and helps to produce it. I want to stress a word in this. Every material or physical effect has to have an adequate cause that precedes and could conceivably produce whatever that effect is. And then a lot of times from the effect you have all kinds of other causes that are sent off. It's basically the domino effect, pun intended, okay? The domino effect, one thing and then they just start to drop one after another. I want to give a few just everyday examples, one for each of these. Let's say, for instance, we travel to another country together, Jeff. We may be doing in about a year. Let's say we travel together to another country and we see a horrible scene. There is a large tree that has fallen over on a house like we saw in a missionary presentation not very long ago. And this large tree, and you can tell it's very green, it's vivacious. It wasn't that it was dead. And it's uprooted and it's lying on the house. And Jeff, you and I, we have inquisitive minds. We want to know what happened that produced this. And then we're told, well, there's this lady, Jeff, and she lives in the village, and man, every now and then she gets that tickle, and she sneezes like an elephant. Force field goes out from her nose, and bam, toppled that tree right over on the house. Okay, let's back up and consider law of cause and effect here. So we have an obvious effect, and that is a material effect. A tree has fallen over on a house. Do we have an alleged cause? Absolutely. The tribal woman with the elephant sneeze knocked over that tree, and she lifted it up from the roof, and she put it on the top of that dwelling. There's just one thing, though, about law of cause and effect. Adequate. is there any kind of human elephant sneeze that could topple a tree and pull it up from the roots? No, not even of this lady. She can't do that. No human being can do such a thing. So we think that's not very reasonable. We keep asking around. And then there's someone else who tells us, oh yeah, well, a week ago we had a tornado that passed through there. It's a pretty good sized one. And it knocked over some trees in the area, and undoubtedly that's along that path. Probably knocked that one over, put it on the house. So as we go back, we still have a material effect. A tree has fallen on a house. Now we have a new proposed cause, and that's not the lady's sneeze, but the tornado that came through. Is that adequate? Is that big enough to do that? Well, that kind of makes some sense, doesn't it? The law of cause and effect. So here's what we have. Evolutionists and creationists are on the same page about this. This is a creation that exists. And we talked about that last week. This is a creation. There's no debate about it. Everybody understands the universe is not eternal. There is a point of creation, and that's the exact terminology that both camps use. There's a creation. That's a material effect. So, following the law of cause and effect, we have to ask, what is an adequate cause that preceded and could have produced a perfect, orderly universe? In one camp we hear, oh, there's a big explosion. Big bang. We have a purported cause. But is an explosion adequate enough to create anything? We've never seen explosions create. Okay, technically a big hole. Well, come on, we're talking about design here, okay? We've never seen an explosion create, in the sense of design, anything impressive. Is it a purported cause? Absolutely. Is it adequate? Is it big enough? No, that doesn't make any sense. But what if there were a being that existed not within but outside of nature? There's no natural explanation for what we have here. Nothing. Nobody's been able to suggest anything that makes any sense. But what if there's a being that exists outside of nature, that is supernatural, and he has all power and all knowledge? If that were the case and he actually exists, would it be conceivable that that would be an adequate cause to produce what it is that we see in nature? Okay. Let's contemplate some other laws of science here. How about the first law of thermodynamics? Thermodynamics is a branch of physics. I like to break words down, the simple mind here. Dynamics refers to power or energy. Thermo, what's that? Temperature or heat. Very good. And all it is just the transfer of energy through heat, is what that means. The transfer of energy through heat. The first law of this branch of physics that deals with the transfer of energy through the implementation of a temperature change states that neither matter nor energy can be created or destroyed in nature. And it kind of goes back to what we were discussing about the water cycle. Marty, I'm thirsty. I need to create some water. No, you can't create water, but you can find water and you can use it. All right, so how is it that I find the refreshing water that I need, Marty? There you go. I have to produce precipitation, right? But that's from, of course, the precipitation that's come down. And we didn't talk about collection. Some would say, well, there's a fourth part, and even more, the water cycle. Yeah, the collection of it. So you can't create new water, but you can collect that which is being recycled within nature. And let's say I want to destroy that liquid water, and so I'm going to apply some real cold to it. All right, what happens? I've made the old-fashioned kind of ice cubes. I can't destroy it, but I've altered its state through. I've changed I've changed its energy through the implementation of a temperature fluctuation. Let's say that I have liquid water, and I say, all right, I've tried cold, and that doesn't work. And here's what I'm going to do this time. I'm going to apply heat, and I'm going to destroy you. And so I have a pot on the stove, and I put that water in there, and I turn that burner on high, and I just let it go and go until there's nothing left in the pot. I did it. I finally destroyed matter, didn't I? No, I can't, no matter how hard. All I did was I just changed its state through the implementation of temperature. And that little cloud that you see above the water, you just changed it through heat from a liquid to a gaseous state. I can't destroy that no matter how hard I try. That's true of matter, and that's also true of energy. The issue with evolutionary thinking, saying we'll just use nature to explain everything, is so there was this matter. Great. From where did that matter come? How did it arise? We don't know. It's just always there. By the way, creationists are often ridiculed because where did God come from? Well, he's always there. Ha ha, idiot! Where did the matter come from? I don't know. It was always there. Do you see the hypocrisy? It's the same problem perceived, although I would suggest much less of a problem than on the other side. Energy all of a sudden arose from within nature. These gases interacted with one another. Boom! Whoa. Let's back up a second. The first law of thermodynamics states energy cannot arise within nature. It has to have a force that propels it. So what was that force that sent that energy into motion? We haven't figured it out yet, but no. You can't go any further than that. It's a violation of one of the most established rules of science. In order for anything to exist, there must be time, space, force, energy, matter. Time, space, force, energy, matter. I encourage you to re-examine the very opening of Scripture. Genesis chapter 1, verse 1. In the beginning, time. God, force. Created, energy. The heavens, space. The earth, matter. The 5 phenomena of physics required for anything to exist are perfectly contained in a very short, tidy sentence to open the Bible. Genesis chapter 1, verse 1. There's nothing that's more scientific than Genesis 1:1. The second law of thermodynamics, also known as the law of entropy, is everything is wearing out and wearing down over time. Matter and energy are becoming less usable, less organized as time progresses. Let me give you an example. Marty knows I have decks on the brain right now, and there's a reason for that. Okay, let's say that you put in this very nice wooden deck, and you're like, man, that's sharp. That's going to look great for the rest of my life and for all eternity. Well, you might think that whenever you put that deck in. You don't do anything to that deck. Then you come back several years later, it actually blew you away. You didn't realize the evolution that occurs with decks over time. You come back, and it's this perfect composite deck now it's evolved into. Isn't it amazing, evolution within nature and how it operates and benefits us? Is that the way things happen? They wind up and they get better over time? What happens to that deck if you leave it untreated and you come back several years later? For that matter, if you treat it and you come back several years later, it doesn't look quite as nice as it once. Everything wears down till it wears out over time. You remember the thought of naturalistic evolution and the origins of the universe? Things start as just this tiny speck, and there's just not much there. It's not orderly. It's not impressive. Boom, and what happens? Organization and order. Things get better and better as time goes on. That's a violation of one of the most established simple rules of physics, the law of entropy. I wish we had more time. We don't. There are 3 places in the Bible, though. Hebrews chapter 1, Psalm 102, and Isaiah 51, all of which state that the earth is becoming less usable over time. In fact, it's stated to be wearing out like a shirt. Now, if you have a shirt and you really like that shirt and you wear it a whole bunch, 3 years later, what's going on with that shirt? You think, oh no, I got a little hole in this shirt. 2 days later, it's the size of Texas, the hole on your shirt. It just wear. That's what's stated in the Bible. The law of entropy. These laws of science are firmly established with the creationary concept, completely violated with the thoughts of naturalistic evolution. There's one, though, to which I want to go back as we close. This one often does come up. Okay, so everything we see is an effect, okay? And everything has to have an adequate cause that precedes it. All right, let's say that we have to have an adequate cause for the universe. Yeah, let's start saying that. That would be great. That produce this material effect. And let's say, supposedly that's God, okay? Then that would make God a material effect, and something would have to produce Him. So you tell me, who made God? Who caused God to be? Well, let's go back and reconsider the law of cause and effect. What's the key word found in that, the descriptor? Material. Thank you, Emily. Material. All right, what's another word for material? Physical. What's another word for physical that we've been using? Natural. Natural. Now, we've already established that nature cannot produce nature. That doesn't make any sense. We've already established that the God of Scripture, He does not claim to be natural at all. What's He claim to be? Supernatural or spiritual. And if that's the case, guess what that means relative to God and the law of cause and effect? He's outside of it. He doesn't answer to that. He created it. He's not material, therefore he's not an effect at all. He's a supernatural cause. We're going to sing later in this week one of the songs with the kids. His fingerprints are everywhere. That's so true. Isn't it neat, though, how little you have to use the Bible to know that God is real? How little you have to use the Bible to know things about Him. Let's not misunderstand. We have to have this as a roadmap to understand how to get to Him, how to have a relationship with Him. Nature doesn't do that for us. But nature declares the glory of God. The sky shows His handiwork all around. His fingerprints are everywhere. Number one, to know that He exists. But number two, just how much He cares. Appreciate your good attention. We'll get started with worship. Can't wait for our study of the age of the earth together. That's going to be a lot of fun. Looking forward to it.